Hello everyone, welcome back to my channel. So in this video, let's solve one more super mesh problem from the subject name called electric circuit analysis for the dependent sources. And I already explained what is dependent source and how we can identify the dependent sources. So now without wasting time, find branch currents using mesh analysis. You can see the circuit diagram now. So it is having one super mesh. So if we are naming here, so A, B, C, D, E, F, G, H. So H, F to Z, there is a super mesh. There is a current source between two loops. Before that, I'll mention the loops now. So here I1 is flowing. So this is loop 1. And here I2 is flowing, and this is loop 2. And here I3 is flowing. This is loop 3. So now, as I explained in earlier problems, so you can see 1 by 9 Vx of current is flowing from F to Z. So that is nothing but voltage dependent current source. And this is depending on voltage Vx. And they are mentioned Vx here, that is voltage drop across 3 ohm along with the polarities. So first analyze the circuit, then you write the mesh equation. So from super mesh, you can write one equation, that is 1 by 9 into Vx. It is flowing upward, remember, direction is upward. And this 1 by 9 Vx current source is in between loop 1 and loop 2. So observe the loop currents from first and second loop. So loop 1 current is flowing downward, I1 is flowing downward, clockwise direction. So this is flowing downward. Similarly, loop 2 current is flowing upward like this. So that the direction of current that flows to the loop 2, that is I2, is having the direction which is same as the direction of mesh current of 1 by 9 Vx. So that I can write here 1 by 9 Vx equals to I2 plus I2, because I2 is having same direction as that of super mesh current, minus I1, because I1 which is flowing opposite to the direction of super mesh, and this super mesh is in between I1 and I2, so that I'm writing this 1 by 9 Vx equals to I2 minus I1. This is the equation from super mesh. But you need to substitute the value of Vx, because they mentioned Vx, that's nothing but voltage drop across 3 ohm resistor. You can see Vx. So I will write Vx now. So Vx, you can rewrite it as, from the circuit diagram, you can write Vx as 3 into current flows to that. So Vx is nothing but 3 into current flows to that. You need to write 3 into, whether it is I2 minus I3 or I3 minus I2, that you have to identify. You can see the I2. So this I2 is flowing from G to D. I2 is flowing from G to D, so that the polarity through the resistor is plus and minus. Similarly, I3 is flowing from D to Z, so this will be plus and minus. Check the polarity of voltage along with the polarities of this current. So I2, which is flowing through the resistor 3 ohm from plus to minus, so that you can write 3 into I2 minus I3. Vx polarities plus minus. I2 is flowing through the resistor 3 ohm plus to minus. That is same as the polarity of Vx, so that I am considering I2 minus I3. So if you're having doubt, you can see here, if there is a Vx like this, the polarity is plus to minus. Okay, just for your information, suppose there are two currents which are flowing, say it as I2 is flowing here and I3 is flowing here. So marking the polarity, current which flows to the resistor from higher potential to lower potential, so that this second loop current is flowing through 3 ohm resistor plus to minus. Here it is plus to minus. So this current which flows opposite to the polarity of Vx, but I2 is flowing through the polarities of Vx, so that you're writing I2 minus I3. That's all. So now if you substitute this Vx to this equation, you can get 1 by 9 into Vx is nothing but 3 into I2 minus I3. That is equal I2 minus I1. 3 ones are 3 3s. I can get I2 minus I3 equals to 3I2 minus 3I1. So again, I'll rewrite this as 3I1. I'm sending this term to the right side. So it becomes plus 3I1 minus 3I2. Okay, plus 3I1 minus 3I2 plus I2 minus I3 equals to 0. So that I can write 3I1 minus 2I2 minus I3 equals to 0. This is equation number 1. So now apply KVL to super mesh loop by neglecting this super mesh. Apply KVL to the loop, so that sorry, you cannot apply KVL to this loop because loop 1 is having current source. So you already know this value of current source, so that this circuit which will be act like this. If you're applying KVL to here, the circuit which will be like this. Keep that in your mind. If there is a current source, you cannot apply KVL to this current source. So it will be open circuited like this, because you don't know the source value. There is a current sources. So that apply KVL to loop 3 here. So now apply KVL to loop 3. Before that, mark the polarities, then write the equations. So you can see the current which is flowing in clockwise direction, so that plus minus plus minus plus and minus based on the direction of current. I'm marking the second polarity. You can also mark first polarity, so that I will write here minus 2I3 minus 3 into I2, I3 minus I2 here, minus 3 into I3 minus I2, that is nothing but minus 3I3 plus 3I2. Similarly there, minus I3 minus 1 into I3 minus I1, that is nothing but minus I3 plus I1 equals to 0. But we know the value of I1, keep that in your mind. So by substituting the value of I1 here also, so 3 into 15, that's nothing but 45. So you can rewrite here 2I2 plus I3 equals to 3I1. 3 into 15 is nothing but 45. This is equation 1. Sorry for that. Not this. Similarly, here you substitute the value of I1. Before that, I will rewrite here I2, 3I2, I3 will be having minus 2, minus 3, minus 1, minus 6I3 plus I1 equals to 0. We know the value of I1, so that I can rewrite again minus 3I2 plus 6I3 equals to I1. So I am sending these 3I2 minus 6I3 into right side. It becomes minus 3I2 plus 6I3. I1, you know that is 15 amperes. This is equation number 2. So we know the value of I1 already. The value of I1 is 15 amperes. They are only given substituting these values. So that solve these two equation 1 and equation 2, will get the value of I2 and I3. So keep your calculator in equation mode. Given two unknowns, so you can substitute 2 equals 1 equals 45. Similarly, minus 3 equal 6 equal 15. You can get I2 as the value of I2 is 17 amperes and the value of I3 is 11 amperes, and you already know the value of I1, that is 15 amperes. That's all. First, you're writing super mesh equation 1 by 9 Vx equals to I2 minus I1, because I2 is having the direction which is same direction of 1 by 9 into Vx. That is super mesh current. So that 1 by 9 Vx equals to I2 minus I1. Similarly, observe Vx. So Vx you can write as 3 into I2 minus I3, because I2 direction is having the same polarity direction as that of Vx. So that 3 into I2 minus I3. Suppose if it is having a minus and plus like this, instead of plus and minus, in that case you write it as 3 into I3 minus I2. So this is about a super mesh problem. So if you're having any doubts regarding this problem, feel free to write in a comment box. At the same time, if you like this video, please do subscribe and share maximum. Thank you so much. Have a nice day.